this is our physics project. The purpose of this project was to prove that the acceleration of an object falling on Earth is always 9.8 meters per second squared, without air resistance. For our lab, we used a motion sensor and 4 textbooks and a stepladder. For our procedure, we first set up the lab, which is the stepladder that we put on top of a desk, and then a motion sensor attached to the ceiling, where I then would climb up the stepladder and hold a textbook under the sensor on the ceiling and then dropped it for each trial. And the data from the sensor would be presented in a velocity time graph on the computer. We did 4 runs, starting off with 1 textbook and then adding another one in the next, and so on and so forth. On the velocity time graph, we took the slope of the graph where the books fell and found the slope using the linear function to see how close to 9.8 meters per second it was. For runs 1, 2, and 3, they were reasonably close to 9.8 meters per second squared, but especially run 4, where we got 9.75 meters per second squared. Run 2 didn't go as well due to an error where the textbook tipped to its side and the motion detected the slant as further acceleration when one side was going up, which resulted in the acceleration on the slope being way over 9.8. So, for our conclusion, based on the data collected from the experiment, we proved our hypothesis right, that the average acceleration of all the textbooks is 9.8 meters per second squared, even with some air resistance. In addition, the pattern of the runs we did shows how the more mass we have, the more accurate the acceleration is, further proving that the acceleration of gravity is 9.8 meters per second without any air resistance.